A represents the sets of integers. Set B represents the sets of whole numbers. Which Venn diagram shows the correct placement of the numbers in the sets? So what we're going to do is, the first thing I'm going to do is I'm going to make sure that I label sets A and B so that I know what I'm looking at. So all of set A, I'm going to label with integers. And then all of set B, I would write whole numbers next to that. And that just helps your brain not look at set A and set B, but instead know exactly what it's looking at. So we've got integers and wholes. Okay, then I need to define integers and I need to define whole numbers. So some examples of integers. Remember, integers are just your whole numbers, but it's the negative numbers. So your integers are your negative numbers. No decimals, no fractions. It also includes whole numbers. And then whole numbers are your positive numbers and 0, no decimals, no fractions. So when we go through, we need to find in set A and set B which numbers are incorrect. So looking at set A, remember set A are your integers, so those should be your negative numbers. But when I look at all of these are positive. And then set B is supposed to be your positive numbers, and all of these are negative. So all of these numbers in here make A incorrect. Then for this one, integers, remember, are your negative numbers with no decimals or fractions. I see a number here, which is 0, which makes this not a set of integers, because the 0 should actually go there. So that makes this incorrect. And then this one, once again, we have some positive numbers that would have been better suited for the whole number category, so that doesn't work. And then for this one, I see my negatives, which is perfect, and then I see my positives and my zeros and my whole numbers, which is perfect. So that one should be D. All right, this one says, David found a sale on steak for $10.50 a pound. What is the total cost of David's purchase if he buys 6.5 pounds of steak? So when we look at this one, what I am seeing is that I am buying 6.5 pounds, and each one of those pounds is going to cost $10.50. So the first one is going to cost $6.50. The second one would cost $6.50. The third one would cost $6.50, and so on and so forth. So if I have this repeated process over and over again, what am I actually doing? I'm actually multiplying. So, sorry, all of those were $10.50. This was supposed to be $10.50. So what I'm going to do is I'm going to multiply 6.5 times 10.50. Now, when I multiply, I don't want to keep these end zeros on because they just make more for me that I have to multiply. So I'm just going to do 10.5 because it's the same thing as 10.50 times 6.5. I start with 5 times 5. 5 times 5 is 25, so I write down a 5, carry my 2. Then I have 0 times 5. 0 times 5 is 0, plus the 2 right there gives me 2. Then I have 1 times 5, and 1 times 5 is 5. I finished with my 5, so I finished with my 2, and the next thing I'm going to do is I'm going to add a 0 on my second row, and I have 5 times 6. 5 times 6 is 30, so I'm going to write down a 0 and carry my 3. Then I have 6 times 0. 6 times 0 is 6. 6 times 0 is 0, and then I'm going to add this 3 up here at the top, and that gives me 3. And then I just have 6 times 1 right here, and 6 times 1 gives me 6. Add it all together, that's 5, 2, 8, 6, and then I have 2 decimal places, so that is 68.25. The next one says find the value of the expression. We have negative 452.63 plus 123.89. So the first thing I'm going to ask myself is, are they the same signs or different signs? They're different signs, and different signs add or subtract. They subtract, so I do 452.63 minus 123.89. This 3 right here is going to turn into a 13. So the 6 right here turns into a 5. 13 minus 9 gives us 4. I can't do 5 minus 8, so that 5 is going to turn into a 15. And then that 2 right there is going to turn into a 1. 15 minus 8 gives us 7. I can't do 1 minus 3, so that 1 is going to turn into a 11, and that 5 is going to turn into a 4. 11 minus 3 gives us 8. And then I can do 4 minus 2, and 4 minus 2 gives me 2. And I can do 4 minus 1, which gives me 3. Drop that decimal straight down, so we have 328.74. Now, we always keep the sign of the bigger number, so which one's bigger, 400 or 100? 400 is bigger, so I put my negative there. Okay, then I have 51.52 divided by 1.6. 51.52 goes on the inside because it's the first number, divided by 1.6, and that goes on the outside. Now, I can't divide by a decimal, so I take this decimal and I move it over once. So I take this decimal and I move it over once. So that gives me 16 going into 515.2. I'm going to list out my 16s facts. So 16 times 1 gives me 16, plus 16 gives me 32, plus 16 gives me 48. Sorry about that. Plus 16 gives me 64. Plus 16 gives me 80. And I'm going to stop there, and we're going to see what that ends up giving us, if we need to keep going. All right, so 16 does not go into 5, but it does go into 51. How many times, looking at your list, would it go into 51? That would be 3 times because of this 48 right here. So we see right here that 3 times 16 gives us 48. Subtract, and that gives us 3. Drop down your 5. 16 goes into 35. How many times? 2. Write down that 2. 2 times 16 gives us 32. Subtract, and that gives us 3. Drop down my 2. 16 goes into 32 2 times. Bring your decimal straight up. That gives us 32.2. And then for this one, I have a negative right next to another negative, and what happens with that? Those turn into positives. So I actually have 17.38 plus 4.2. Remember, when I add or subtract decimals, I have to line them up. So I'm going to start by plopping down 2 decimals. And then before my decimal in the first one comes the 17. And then after it comes the 38. And then my second one, 4, comes before the decimal. And then 2 comes after. And then we add it up together. We have to add a 0 to go right here with it. And I start with 8 plus 0, which gives me 8. 3 plus 2, which gives me 5. Drop that decimal down. 7 plus 4, which gives me 11. So I write down a 1, carry my 1. And then 1 plus 1, which gives me 2. So that's 21.58.